Okey. Assalamualaikum warahmatullahi wabarakatuh. Saya Kusubti Azam dan kawan saya Azra Zahirah binti Abdul Malik. So kami akan present bahagian tajuk map projection. This our member. Saya Karen Sanisa, nombor metrik 01DGU20F 1055 serta Azra Zahira binti Abdul Malik, nombor metrik 01DGU20F 1048. Before we starting, first I will intro. First kita akan introduction, second basic type of projections, error and distortions, map projection in Malaysia. What is a map projection? A map projection is a systematic representation of all or part of the surface of a round body, especially the Earth on a flat surface. The process of transferring information from the Earth to a map causes a very projection to distort at least one aspect of the real world, either shape, area, distance, or direction. Basic type of a projection. Type of a projection, certain map projection always of a displaying the Earth in the most accurate ways by scale are more well known and used than other kinds. Three of these common types of map projections are cylindrical map projection, conic map projections, azimuth map projection. For cylindrical map projections, cylindrical map projections are one way of portraying the Earth. This kind of map projection has straight coordinates line with the horizontal parallels crossing meridians at right angle. All meridians are equally spaced and the scale inconsistent along each parallel. Cylindrical map projections are great for comparing latitudes to each other and are useful for teaching and visualizing the world as a whole, but really are not the most accurate way for visualizing how the world really looks in the entirety. Type of a cylindrical map projection you may know include the popular Mercator projection, Cassini, Gauss-Krüger, Miller, Berman, Hobodaya, and Gell-Peter. Okay, this is a map of a cylindrical map projection. The Mercator map projection is one of the most well-known cylindrical map projection. Next is a conic map projection. Conic map projections include the equidistant conic projection, the Lambert-Conformal conic, and Albus conic. These maps are defined by the Kuhn constants, which dictate the angular distance between the meridians. These meridians are equidistant and the straight line which are converge in the locations along the projections regardless of if there's a pole or not. Conic map projections have a parallels that cross the meridians at right angle with the constant measure of a distortions throughout. Conic map projections are designed to be able to wrap around a cone of the top of a sphere globe, but are not supposed to be geometrically accurate. The Albus projection is an example of a conic map projections. Distortions in the conic map makes it inappropriate for use as a visual of the entire Earth, but does make it great for use visualizing temperate regions, weather maps, climates, projections, and more. Next is the azimuth map projection. The azimuth map projection is an angular given 3 B and C. The azimuth from point B to point C depicts the angle someone will have to look or travel in order to get to A. The main feature of an azimuth map projections are straight meridian lines radiating out from the central points parallels that are circular around the center point and the equidistant parallel spacing, like put in the three different categories, is orthographic, stereographic, and the genomic can also be used. Azimuth maps are beneficial for finding direction for any point on the Earth using the center point as a reference. This is a map of the Lambert azimuth equal area projections. So I pass to Azza Zahira to the next slides.
Alright, my name is Nur Azra Zahira binti Abdul Malik. My metric number 01DG20F1048. I will continue present from NISA about error and distortion. Alright, distortion ellipse help us to visualize what type of distortion a map projection has caused, how much distortion has occurred, and where it has occurred. The ellipse show how imaginary circle on the globe are deformed as a result of a particular projection if no distortion had occurred in the process of projecting. So, when positioned on the graticle transform to position on a projected grid, four types of distortion can occur. First one, distortion of size. Second, angle. Third, distances, and fourth, direction. Alright, so for equivalence, equal area projection maintain correct proportions in the size of area on the globe and corresponding area on the projected grid. Notice that the shapes of the ellipse in the cylindrical equal area projection above are distorted, but the area each one occupies are equivalent. Equal area projection are preferred for small scale thematic mapping, especially when map viewers are expected to compare size of area features like countries and continents. Alright, for conformality, the distortion ellipse plotted on the conformal projection shown above in very substantially in size, but are all the same circular shape. The consistent shape indicate that conformal projections, such as this Mercator projection of the world, keep angle measurement from the globe to the plane accurate. In other words, an angle measured by a land surveyor anywhere on the Earth's surface can be plotted on a conformal projection at its corresponding location without distortion. This useful property explains why conformal projections are almost always used as the foundation for large-scale surveying and mapping. The transverse Mercator, Lambert, Comfort conic, and Polar stereographic are three of the most common conformal projections. Alright, for equidistance map projection allow distances to be measured accurately along straight lines radiating from one or 2 points only. This shows that distances are true to scale along every meridian.